Okay, yes. So yes, in the last class we were discussing digital differential analyzer algorithm, right? Uh, so yes, since let us check the problem. Let us check one of the problem, right, with respect to DDA, and then we should go further. Right? So now the numerical or the problem is, right, to draw a line by DDA algorithm, right? So where the two endpoints are 1 1 and 4 3. Okay, where x1 is 1, y1 is 1, x2 is 4, y2 is 3. Okay. So first and foremost thing is to find the slope, because based on the slope only, right, that is based on dx and dy value only, right, we will be deciding what are our next points. So first we need to find the slope, that is m, that is dy by dx. So dy by dx is 3 minus 1 y2 minus y1 divided by x2 minus x1. So that turns out to be 0.67. Okay. If the slope turns out to be less than 1, then we have clearly seen that, right? So it is a case wherein our straight line is moving towards, is close to x-axis. That means x-axis will be moving correctly, but the problem is with y-axis. Y-axis will not be moving. Y-axis will be moving less. Correct, right? So yes, we will see we will see our algorithm, right? So where here dx is 3, dy is 2. That means this case dx is greater than or equal to dy, right? So what are my first point? My first point is 1 comma 1. My first points are 1 comma 1, right? I need to find the next point. Okay, right? So first point is 1 comma 1. My slope turned out to be 0.67. That is my dx is greater than dy. So I will choose this section, right? So where my xi plus 1 is equal to xi plus delta x, where delta x is 1 here. So my xi plus 1 is equal to xi plus 1, right? So my x next will be 1 plus 1, that is 2. And coming to y next, right? What is my y next? yi plus 1 is equal to yi plus m, right? So what is m? M is equal to 0.67. What is yi? Yi is 1. So 1 plus 0.67, it is 1.67. Okay, next thing, right? So now I am at 2 comma 1.67. Okay, where I am 2 comma 1.67. So what is my next point? My next point is 3, 1.67 plus 0.67, right? So it turns out to be 2.34. Now I'll be to 3 comma 2.34. What is my next point? Xi plus 1, 4. Yi plus m is 0.67. That is 2.34 plus 0.67. It is 3.01. Okay, right? So I will stop here, right? Because my endpoint I have got 4 comma 3. I have reached 4 comma 3. So I will stop here. Fine, right? So now let us plot it. Okay, right? See, this type of structure you need to write it. Fine. So for plotting, where this particular pixel is 0 comma 0. Okay, this particular pixel is 0 comma 1. This particular pixel is 0 comma 2. This particular pixel is 1 comma 0. This particular pixel is 1 comma 1, like this. Okay, right. So now let us come to the first point. What is my first point? 1 comma 1. Okay, I will plot this pixel 1 comma 1. Okay, now I will color this pixel. Fine. So now come to the next point. What is my next point? 2 comma 1.67. Okay, 2 x-axis 2, fine. 1.67. I don't have that 1.67 pixel. How are my pixels arranged? My pixels are arranged based on integer increments. As a 0, 1, 2, 3, 4, 5. On the same lines, right? On the y-axis also 0, 1, 2, 3, 4, like this, right? I don't have floating point arrangements here. Okay, right? What I can plot if my coordinates are integer, right? If my coordinates are floating point, I cannot plot exact here, right? So 2 1.67, right? I don't have that particular pixel. 2 I have 2 1 or 2 2 pixel. I don't have 2 comma 1.67 pixel. This is a problem now, right? So what they did was, right, they tried to round off the things. Okay, right? Anything above 0.5 they rounded off to next integer. Anything below 0.5 they rounded off to previous integer. Okay, right? So here this 1.67, it is above 1.5, so they rounded off to 2. Okay, right? So x next is 2, y next is also 2, 2 comma 2, right? So next, yes, this was rounded off to 2, where this 2.34, 0.34, this is less than 0.5, so they rounded off to previous integer, that is 2. Okay, so this becomes 3 comma 2. Okay, right? So now what they did, this round of operation, right? So this was the adjustment that they did. This is not the exact procedure, right? So this was the main disadvantage of digital differential analyzer algorithm, DDA algorithm, right? So where this rounded off, this rounding of this roundup of floating point numbers was happening, right? And this was not the exact thing that was supposed to happen, right? And this was a major error or major problem with this algorithm, digital differential. Obviously, this algorithm was very fast because there was nothing to calculate, only this much. They was calculating slope. It was checking dx is greater than dy. If that was the case, right, it was doing this. Else, it was doing this. Right, that's it. The procedure was simple, so it was fast. But the problem was its floating point calculations. Right, floating point calculations which it was getting. I could not find the pixel for that, so I was rounding off to the nearest pixel, and that was not the exact one that was required, right? So now there was a need to address this problem, where I need to get only integer increments and I need to get only integer coordinates. Okay, right? So now to address this, right, we came up with a new algorithm, right, called as Bresenham's line drawing algorithm, right? You people may have heard of this Bresenham's line drawing algorithm already. I think Kotesh sir has done a part of it, right? Now today let us learn the thing. Okay, what is Bresenham's line drawing algorithm, and how we will plot it. Okay, fine, right? So now Bresenham's line drawing algorithm, fine, right? So this Bresenham's line drawing algorithm, what they created, right, what they found out, right, was accurate and efficient, and it used only incremental integer calculation. Integer, okay, this you have to keep it in mind. Incremental integer calculations, right? It consisted of only integer calculations, right? So obviously I was getting a whole number which was easy to plot with respect to pixel. Fine, right? So this method of line segment was very easy to plot. For the this method was very easy, or it was described for a line segment with a positive slope and less than 1. Okay, right? So this Bresenham's line drawing algorithm best suited for the lines which has positive slopes, right? That too less than 1. Okay, right? So we'll discuss this Bresenham's line drawing algorithm for a positive slope which is less than 1 and also greater than 1. Okay, less than 1 we will concentrate more. Okay, right? So now what actually this Bresenham's line drawing algorithm was doing? Okay, kindly concentrate, observe what I am telling, right? If you find anything confuses, right, kindly you can interrupt me in the middle and you can ask me, right? So now consider this is my line segment. Okay, right? So when I'm talking about this pixel, Okay, right. So there is no confusion with this part of line. This part of line is lying in only exactly this pixel, and I will illuminate this pixel. Okay, right. So in this pixel, exactly this part of line is falling, and I will illuminate this pixel, and I will call this particular point as xk, yk. Okay, I will call this point as xk, yk. Right. So now coming to the next pixel to illuminate. Okay, right. Coming to the next pixel to illuminate, right? See here, this part of line. Okay, right. You can see here, right? A part of line is falling in this pixel. Okay, another part of line is falling in this pixel. Okay, right. So now coming to the next column, right? I should ignite only one pixel. Whether I should ignite this pixel or I should ignite this pixel. Okay, but the problem is, right, so a part of the line is passing through this pixel and a part of the line is passing through this pixel, right? So now the problem came, right, where, which pixel I need to ignite, whether I need to ignite the above pixel or whether I need to ignite this below pixel, right? So what Bresenham is actually a person, right, who founded out this algorithm, who gave us this algorithm, right? So Bresenham, taking the property of line, right, he did some calculations, right, and finally he came up with a solution for this, right? So how to decide which particular pixel to ignite? Okay, right. So this was the major thing what he did, right? So he came up with his own algorithm using the equation of line, and he finally found out, right, which particular pixel to ignite in these type of cases, whether to ignite the below pixel or whether to ignite the above pixel, right? See, below pixel, above pixel means, right? So now whenever I found out a particular pixel, right, so finding the next pixel, right, so and finding the next pixel means obviously I will move horizontally. There is no doubt with respect to that. After this pixel, right, I will obviously move to the next one with respect to x coordinate. X coordinate, there is no problem. From xk, definitely I need to move to next one, that is xk plus 1. Okay, now the problem is with respect to y, whether I need to increment yk or whether I need to whether I need to go for yk plus 1, because a part of a line is falling in this and a part of a line is falling in this, right? With respect to x coordinate, okay, which is the next point x coordinate, there is no problem in that. It is xk plus 1, that is the next x value. Okay, now the problem is with respect to y, whether I need to ignite the same y or whether I need to ignite the above y, right? Fine. So that means, see here, what is my confusion? My confusion after xk yk is, right, whether to go for xk plus 1 yk, that is xk plus 1 yk is this. Okay, whether I need to go for this xk plus 1 yk, right, or xk plus 1 yk plus 1, this one. Okay, right, that is this xk plus 1 yk or xk plus 1 yk plus 1. Okay, right, this was our major problem. Okay, right, this was our major problem, that Bresenham, right, using some concept of lines and some mathematics, right, he solved this for us, right, whether to go for xk plus 1 yk or xk plus 1 yk plus 1. Andre x ಏನು problem ಇಲ್ಲ, right? So it may be anything, I will increment by 1, I will go to the next x, right? The problem is with only y, whether I need to remain in the same y or whether I need to increment y to the next ಅಂತ. Okay, right? So now let us see how he solved this, right? So how he decided whether to go for this or whether to go for this. Fine, right? So the logic what he applied was, you see here, fine, right? So now consider if I have a line. Now consider this is my line. Okay, right? There is no problem with this. Okay, when I come to this part, right? So some part is here and some part is here. So this pixel or this pixel, now that is my problem. Right? So now what he did was, right? He found out, right? So the difference between the distance with respect to the upper pixel and lower pixel. That is, right, from this line, he found out what is the distance from here to here. On the same lines, right, for lower pixel, he found out what is the distance from here to here. Okay. See, that is what he did, right? So this is my line. So what he did was he found out the distance between this to above pixel, and he found out the distance between this to the below pixel, right? So whichever distance was less, he moved the pixel to there. Ashte, right? This was a logic he used, right? And he did lot of mathematics with respect to that logic, and he finally came out with some decision, right? Whether to go for the next pixel or whether to go for the upper pixel, right? See, this is bresenham's line drawing algorithm, right? So I will tell you the logic, right? Kindly follow the logic. If you find anywhere anything finding confusions, right, kindly interrupt and we shall solve it there itself and move further. This is an important line drawing algorithm, and it is also there in the lab. Okay, right? So now what is my problem here is, right, uh, after a particular point I choose which point to choose next, whether xk, if xk yk is the point that I have chosen, next which is the next point that I need to choose, whether the next horizontal point or the upper point. Okay, right? That is xk plus 1 yk na athwa xk plus 1 yk plus 1 na, right? In these two I have confusion, right? So that is why this that is what this bresenham cleared. Okay, see, with x I don't have any problem. Next ಗೆ ಹೋಗೋದು. Okay, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ xk will move by 1 unit, right? My problem is what to do with y, whether to retain y here only or whether to increment y also. ಅಷ್ಟೇ, right? So x ಬಗ್ಗೆ ನೀವೇನು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋಗಿಲ್ಲ. X simply whatever may be the case, right, you will move x by 1 unit. Okay, right? So we have to decide, right? So what will be my y? Fine. See, right? So based on some value, right, he decided that, right? So what is that value? We shall see here, right? So first we will calculate the slope. Okay, y2 minus y1 divided by x2 minus y1, right? Definitely in the program, sorry, in the problem or in the program, right, you will be giving two coordinates, right? Starting coordinate and ending coordinate, right? So between these two coordinates you need to go on filling the points, right, so that it looks like a straight line. Fine. So we will find the slope, right? How do you find the slope? It is m2 minus y2 minus y1 divided by x2 minus x1, where x1 y1 are the first point coordinates and x2 y2 are the last point coordinates that they have given, right? So now this I call it as dy, next this I call it as dx, right? So yes, for the first vertex they will be giving the first vertex and they will be giving the last vertex, alpha, right? So first vertex there is no problem, you will plot the first vertex. Okay, right? So now I need to decide the second vertex. Okay, right? Second vertex decide ಮಾಡಬೇಕು, right? ಅದೇ ಸೇಮ್ ಕೇಸ್ ಇದೇ ತರ, right? So first vertex ಅವ್ರು ಕೊಟ್ಟಿರ್ತಾರೆ, ನೀವು first vertex ನ plot ಮಾಡ್ತೀರಾ. So second vertex you have to decide whether second vertex comes here or second vertex goes here, right? So to decide that, what they have told you is, right, so this is p is decision variable. Okay, right? First calculate this decision variable. Okay, this decision variable equation is given by 2 dy minus dx. You know dy, you know dx, right? Calculate this 2 dy minus dx, right? If this decision variable turns out to be positive ಅಂದ್ರೆ greater than or equal to 0, less than or equal to 0 andre negative, right? If this decision variable turns out to be negative, right, you follow this procedure. Okay, right? If this decision variable turns out to be negative adre idu p less than 0, right? If this decision variable turns out to be negative, you will follow this procedure. If this decision variable turns out to be positive, you will follow this procedure. Okay, right? So now, if my decision variable turns out to be negative, right, what you will do? Yes, you will increment x by 1. That is common, right? But y, you will not do any changes, right? So your y value, new y value will be the previous y value. Okay, that means what they are telling is, if the decision variable turns out to be negative, this is the pixel you will choose. Right? This is the pixel which says x k plus 1, that is x incremented by 1, y remaining as it is. Okay, na? Right? If the decision variable for the second vertex, I'm talking about second vertex. Okay, right? Please keep in mind second vertex. From the third vertex, it changes. Okay, right? I'm talking about only second vertex, right? For calculating the second vertex, the decision equation is this. First vertex, it will be given, you will plot that first vertex. For the second vertex, you will use this decision variable. Okay, 2 dy minus dx. If this turns out to be negative, what you will do? You will increment x by 1, that is usual procedure. You will not do any change in the y. Okay, if for the second vertex this p turns out to be positive, right, or 0, fine, what you will do? You will increment x, that is usual procedure. You will also increment y, right? That means, right, you will be choosing this pixel, right? So x is also incremented by 1, y is also incremented by 1. Okay, na? Right? And this is for the second vertex, right? So if you are while checking for the second vertex, if the decision variable was less than 1, what you will do? X you will increment by 1, y you will not change anything, right? So for the third vertex, okay, for the third vertex, again you need to decide where you need to place that vertex, right? So for that, what decision variable you will use is, right, you will use this decision variable. This decision variable is only for the second vertex. Right? Once the second vertex find out ಆದ್ಮೇಲೆ ಈ ಕಡೆಗೋ ಹೋದ್ಮೇಲೆ, ರೈಟ್, ಇದ್ರ ಕತೆ ಆಯ್ತು, ಡಿಸಿಷನ್ ಈಕ್ವೇಶನ್ ಆಗೋಯ್ತು. ಇದನ್ನ ಮತ್ತೆ ಯೂಸ್ ಮಾಡಲ್ಲ, ರೈಟ್? ನೆಕ್ಸ್ಟ್ ಯೂಸ್ ಮಾಡೋದು ಗ್ರೇಟರ್ ದ ಲೆಸ್ಸರ್ ದು, ಅವೆರಡಕ್ಕೂ ಸಪರೇಟ್ ಡಿಸಿಷನ್ ವೇರಿಯಬಲ್ ಇದೆ. ದಟ್ ಡಿಸಿಷನ್ ವೇರಿಯಬಲ್ಸ್ ವಿ ವಿಲ್ ಯೂಸ್, ರೈಟ್? ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್ ಅಗೈನ್, ಓನ್ಲಿ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ವರ್ಟೆಕ್ಸ್ ಯು ವಿಲ್ ಯೂಸ್ ದಿಸ್. ಫಸ್ಟ್ ವರ್ಟೆಕ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ನೀವು ಪ್ಲಾಟ್ ಮಾಡ್ತೀರಾ. ಸೆಕೆಂಡ್ ವರ್ಟೆಕ್ಸ್ ಡಿಸಿಷನ್ ಮಾತ್ರ ಈ ಈಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ, right? Once you come up with less than or greater than 0, right, next you will be using the respective decision variables for further vertexes. Okay, right? So now if your second point turns out to be this one, right? So x you will increment by 1, y you will not change. For the third vertex, okay, decision, what to do, right? You will use this decision variable, p is equal to p plus 2 dy. Okay, on the same lines, if for your second vertex, right, if your decision variable was positive or 0, then you would have come this way, where you would have incremented x also by 1 and y also by 1, right? And your new decision variable for the new decision for third vertex will be with this equation. Okay, greater than 0 adre you will increment both, and for the next vertex, right, the decision equation will be this: p is equal to p plus 2 dy minus 2dx. Okay, right? So then again you will follow the same thing. If this p turns out to be negative, you will come here, right? You will increment x, you will not do any change with respect to y. And for the next vertex decision, you will use this decision variable, p is equal to p plus 2dy. Okay, and again if it turns out to be negative, again you will follow the same procedure, and for the next vertex decision will be based on this equation, right? There it turns out to be positive, you come to here, right? You will increment both x and y, and your new decision variable and the decision for the next vertex will be on this equation, right? Only for the second vertex, right? So your decision equation will be this. Okay, first vertex it will be plotted as given. For the second vertex where you need to plot, your decision will be this, right? So from the next vertexes, it will be based on the respective decision variable values. Okay, fine, right? How you got these decision variables? This is a very good mathematics, right? So which requires more than an hour to discuss that, right? Very interesting and very good mathematics, right? So if you have interest, you can go through that mathematics I have given in notes, right? But if you find it difficult, don't scratch your head more. Okay, that will not be asked for your examination. This will be asked for your examination, right? A problem on bresenham's line drawing algorithm. Okay, right? And this algorithm you have it in your lab also, right? Now let us see now let us see how we will be solving that bresenham's line drawing algorithm, right? So now consider, this is the problem that they have given, right? Draw the line using bresenham's line drawing algorithm with the endpoints 2010 and 3080, right? That means this 2010 is the starting point, and this 3018 is the last point, right? So from 2010 to 3018, you should go on finding the points using bresenham's line drawing algorithm, right? So when you plot those points, right, it will look like a straight line. I will show you. Okay, right? So now, what are the things you were required there, here, right? So to go on finding the decision variables and all those things, right? So I require 2 dy, sorry, dy. I require dx, right? So and I require 2 dy and the value of 2 dx, right? So those are the things that I require. Correct? Huh? First, I will find out those things. Fine, right? So first, I will find out delta x. Okay, delta x is x2 minus x1. This is x2, 30. 20 is x1, 30 minus 20, right? And delta y, it is 18 minus 10, y2 minus y1, right? So it is 8, right? So delta x, delta y we have got. So 2 delta y is 16, 2 delta x is 20. Okay, delta x 10 is there, 2 delta x 20, delta y 8 is there, 2 delta y 16. And this also we require 2 delta y minus 2 delta x to mod it so that it becomes easy for us. 2 delta y minus 2 delta x is minus 4. Okay, right? So now first point I will plot 20 comma 10. Okay, so next point I need to decide which is the next point, right? So from 2010 I need to go to 2110 or 2111. I need to decide, right? 2010 to 2110 or 2111, because we are clearly seeing, right, from a particular point, right, I will be going to if my previous point was xk yk, I will be going to xk plus 1 yk or xk plus 1 yk plus 1, right? On that I am telling, right, so 20, if I am at 2010, right, I need to decide whether I need to go for 2110 or 2111. Okay, right? So now, yes, for the second point, right, what is the decision variable that I have, right? For the second point, right, the decision variable that I have is, right, 2 dy minus dx. Okay, right? First variable, you will first vertex you will plot. For the second vertex, what is the decision variable that I have? P is equal to 2 dy minus dx, right? So let us go with this. P, that is P is equal to, right, second point, right? So 2 dy minus dx, right? What is 2 dy? It is 16. What is dx? Dx is 10, right? So 16 minus 10, my decision variable turned out to be 6. Okay, right? If my decision variable turned out to be 6, which is greater than 0, right? So if it is greater than 0, what we will do? Okay, if it is greater than 0, right, what I will do, I will increment both x and y, right, and for the next vertex, right, I will use this decision variable, right? So what I have done from 2018, see, from 2018 I have moved to 2111. That means I have incremented both x and y. Okay, right? Now from 2111 I need to find out whether I will need to go for 2211 or 2212. Okay, right? So yes, for that, right, obviously my decision variable is 6, which is positive. right? So which is greater than 0, right? So obviously I need to use this p is equal to, that is new p is equal to old p plus 2 dy minus 2 dx. New p is equal to old p plus 2 dy minus 2 dx, right? So that is this new p. Okay, if my decision variable turned out to be greater than 0, that means positive, right? So the next point that I plot is xk plus 1, yk plus 1, and the what is the decision equation that I use for deciding about the next vertex? It is pk plus 1, that is next decision variable is equal to old decision variable plus 2 dy minus 2 dx, right? So let us go to this p1. Okay, next, right? So pk plus 1 is equal to pk. What is this pk? Old decision variable. What was that? It is 6 previous. Okay, 6 plus 2 dy minus 2 dx. What is 2 dy? 16 minus 2 dx, 20. 16 minus 20 is minus 4. So now it is 6 minus 4, it is 2. Again it is positive. My decision variable, again it is positive. So it is greater than 0. So as it is greater than 0, what I will do? Again I will increment both x and by y by 1. This becomes 22. This becomes 12. Right? And for finding my next vertex, I will use again the equation with corresponding to pk, that is decision variable greater than 0, right? That is old pk plus 2 dy minus 2 dx. What I have done, 2 dy minus 2 dx calculate ಮಾಡಿ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೀನಲ್ಲ, it is minus 4 ಅಂತ. I will use directly that, right? So my next one will be right to old pk plus 2 dy minus 2 dx, it is minus 4, right? 2 minus 4, now it is minus 2. Okay, when it is minus 2 means, right, when it is less than 0, what I will do? Where I will go? Right? When my decision variable turns out to be less than 0, what I will do? I will increment x by 1, but I will not change the value of y. I will keep the previous value of y as it is. And for the next vertex, which is the decision equation I use, p is equal to, that is new p is equal to old p plus 2d y. Okay. Now let us see what I have done. Yes, what I have done, x I have incremented by 1, but y I have kept as it is. Alva, y na hange ittidini, x na obviously increment madidini. Fine, right? So for the next decision, what I have used, right? So I have used this formula. New pk plus 1 is equal to pk plus 2dy, as my previous decision variable was negative. Okay, right? So old pk, what is old pk? Old pk was negative minus 2, minus 2 plus, right? So what is the 2 dy? 2 dy ala. What is 2 dy? 2 dy is 16, and then minus 2 plus 16, it is 14. Oh, again it became positive. Again it become positive, that means it is greater than 0. When it is greater than 0, what I will do? I will increment both x and I will increment y also. Okay, right? And my next vertex decision is based on this equation. Pk greater than 0, right? So what pk plus 2 dy minus 2 dx. 2 dy minus 2 dx is minus 4, right? So what will be my next pk value? It is 14. Old pk, right? Minus 4. 2 dy minus 2 dx. Minus 2 dy minus 2 dx, right? So minus 4, right? So this gives me 10. Again it is positive. Okay, right? So again I will increment both x and y, right? Fine. And again for the next vertex, I will use again this pk plus 1 is equal to pk plus 2 dy minus 2 dx. That is 10, right? So 10 minus 4. 2 dy minus 2 dx illa calculate ಮಾಡಿಟ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೀನಲ್ಲ, minus 4, right? So pk, old pk was 10 plus 2 dy minus 2 dx is minus 4. 10 minus 4, it is 6. Again it is positive. Again I will increment both x and y, right? So like this you need to again again I have incremented again we have incremented both x and y, right? So as it is positive, right? So again for the next point, right, you need to again choose the same equation. Pk plus 1 is equal to pk plus 2 dy minus 2 dx, where your current old pk is 6, right? And minus plus 2dy minus 2dx means it is minus 4. So 6 minus 4, 2 you will get. Again it is greater than 0. Again you will implement both x and y. Okay, right? So this logic you need to go on applying, right? Until at some point, right? So your vertex will stop at 30 comma 18. That is your end point. Okay, right? So once you get all your point, right, you need to digitize. They will ask you digitize the Bresenham's line drawing algorithm. Digitize and right, you need to show how that line looks like. Fine, right? After finding all the points between the two end points they have given, right? See, this is what we have to show. Okay, right? You need to write this table also, right? So first, right, I got my decision variable was 6. So from 20, 10 I changed it to 21, 11. Next my decision variable was 2. I changed it to 22, 12. Next it was minus 2, 23, 12. Like this I did it, right? So till here I stopped, right? My decision variable was 6. I went to 26, 50. Next it will become 2, where I will increment both. Next it becomes negative. I will increment only x and I will keep y as it is. Like this I go on doing. At some point of time, exactly, see, after finding 10 points, right, it stopped here. 30, 18 in it. Okay, there I will stop, right? And then you need to have a layout like this. Okay, right? So ಈ ತರ layout ಇರಬೇಕು, right? Empty layout where it contains the squares. Okay, right? And then you need to plot, and then you need to give the numbers to each square. Okay, right? So 20 x-axis, so 20 in the 30 ವರ್ಗು ಅಲ್ವಾ, right? So this pixel will be 20, this one will be 21, this one will be 22, this one will be 23, 24, 25 up to 30. On the same lines coming to y, it is from 10 to 18. So first one will be 10, next 11, 12, 13, 14, 15, 16, 17, 18 you should have, right? And you should go on plotting. Okay, darken ಮಾಡ್ತಾ ಹೋಗಬೇಕು ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್ ನ, ಅಂದ್ರೆ ಪಿಕ್ಸೆಲ್ ನ, ರೈಟ್? ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ, ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ 20, 10. Okay, I will plot it. Next, what I have got, next point 21, 11 I got it. You plot that 21, 11. Okay, next 22, 12, plot that, right? Next 23, 12, 23, 12 you plot this, right? So next 24, 30 you plot this, right? Like this you go on plotting, right? And this is with respect to micro observation of the line. Okay, when you observe it at a very micro level, right, you find line like this. None of the line will be completely straight up. Okay, right? Well, see, who knows, right? GL underscore lines ಅಲ್ಲಿ ಇದೇ Bresenham's line drawing algorithm use ಮಾಡಿರೋದವರು. Okay, right? So in GL underscore lines primitive, they have used this Bresenham's line drawing algorithm only, right? So how do you do that, right? GL underscore lines, within that you will give two vertex ಅಂದ್ರೆ starting end vertex ಕೊಡ್ತೀರಾ, right? So between those two vertex, right, it plots all the points using Bresenham lines drawing algorithm, and it looks like a line, right? This is very micro observation of the line when you are looking at, right? So you will be looking from a very far distance, right, and it looks like a line, clear line. Fine, right? So this is about Bresenham's line drawing algorithm. Fine. So yes, I have posted this PPT of first module, and also that documentation where I have done the problem. Okay, right? So I have stopped till here. Okay, right? Now it is your responsibility to complete it up to the end point. Okay, if you find any confusions while doing it, right, so kindly give me a call or text me or contact me, right? I will get it this solved, right? This is a guaranteed problem. Okay, you can check in any of the question papers, right? So your second question 2A will be this. Okay, right? Guaranteed question, simple question, easy problem to solve it, and you can solve it. Okay, fine, right? So now this is about circle, right? Next class, very interesting again, right? So now see, checking some properties of Bresenham's and DDA, right? See, Bresenham's line drawing algorithm, it uses only incremental approach. Okay, right? See, in Bresenham's line drawing algorithm, you plotted the points, right? Nowhere you got floating points. alva, right? Everything was integer calculations. Fine. So bresenhams used incremental approach. Okay, right? Increments, so right, integer increments, right? So DDA, this also used incremental approach. Along with that, it also used approximation approach, round off madadalla, right? So that was the disadvantage of DDA. Right? Incremental approach ಮಾಡೋದು, along with that approximation ಮಾಡ್ಬಿಡ್ತದೆ. Okay, right? So this was the disadvantage of DDA, right? So here increments were based on decision variables. Here there we use simple logic to do increments, alva, right? So hence this bresenham's line drawing is slower and DDA is faster. ಇಲ್ಲಿ ಡಿಸಿಷನ್ ವೇರಿಯಬಲ್, ಆ ಡಿಸಿಷನ್ ವೇರಿಯಬಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ದೆನ್ ಯು ನೀಡ್ ಟು ಡಿಸೈಡ್ ವಿಚ್ ಸೈಡ್ ಟು ಗೋ, ಅಂಡ್ ಅಗೈನ್ ಯು ನೀಡ್ ಟು plot, again you need to find it out what the coordinates, right? So many work was there, right? Here there is no logic, there is simple logic. Okay, dx greater ಇದೆಯಾ dy greater ಇದೆಯಾ ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ ಇಂಕ್ರಿಮೆಂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬಿಟ್ರಿ ಕೋಆರ್ಡಿನೇಟ್ಸ್, right? So this was slower. Okay, right? Bresenham is slower, but DDA is faster. Okay, right? And coming to efficiency, obviously bresenham is more efficient compared to DDA, because DDA used approximation approach, which was not justified approach. Okay, right? So yes, this was about discussing this digital differential algorithm and bresenham's line drawing algorithm. Right? So PPT is there. Meghana,
Yes, sir.
again your work.
Okay, sir.
Okay.